Okay, folks, this is from 8.2, and this is where we're going to start talking about working with equations. I think the directions were repeated twice, so let's just read it one time. Find all solutions on the interval. So as I go around the unit circle from 0 degrees all the way around to, back again, what are the angle values that satisfy the equation? All right, so let me do 2 since it's an even problem. 2 sine of theta equals radical 3. Let's solve for the trig ratio. So sine of theta is equal to radical 3 over 2. Now we've seen this enough. We know that the sine is radical 3 over 2 right here and right here. So the question is, what are those angle values? Well, this angle is 60 degrees or pi over 3, and this degree angle value is 120 degrees or 2 pi over 3. Okay, so it's asking what angle values here and here from the domain all the way around the unit circle would satisfy that equation, and then you have it right here. I would leave your answer choice like this. You could put a comma between them if you want to. In essence, that is how you do all of these problems. Now, there's some tricks along the way. You can watch some of my other videos on that, but let me do a couple more of your assignment problems here. Okay, now if you look real carefully at this set of problems, you realize the directions are slightly different, ever so slightly. So here it says find all solutions. Find all solutions. And so this means we want to know, if you had a sine function and the values were true here and here, you got to keep going that way. You got to keep going that way. There's a lot of possible solutions. Let's do an even problem. Let's do number 6, okay? So 2 sine of pi over 3x is equal to radical 2. Well, let's divide by 2. So the sine of pi over 3x is equal to radical 2 over 2. Now, do keep in mind that this is the angle value, and it's equal to a plus radical 2 over 2. So the angle value, pi over 3x. Now, where is sine positive radical 2 over 2? One of them is pi over 4, right, plus every 2 pi n. And another place that it's true is 3 pi over 4. So again, my angle value is equal to 3 pi over 4 plus 2 pi n. Okay. Now, remember, we have to solve this for x. So we're going to multiply both sides by 3 over pi. Now, when I do that on the left side, I get x is equal to, this is going to be 3/4 plus, let's see, what's going to happen here? I'm going to have a 6, and pi's are going to divide out, and then I'm just going to have n. Okay, so let's figure this one out first. Remember, n is the number of times around the unit circle you go. N could be like -2, -1, 0, 1, 2, 3. Well, it said find all solutions, and actually, folks, this is the answer. These are all of the possible values for x. It didn't say between 0 and 2 pi. Now remember, that's just one of the solutions. Here's the other solution right here. So we're going to do the same thing again. We're going to multiply both sides by 3 over pi to solve for x. Okay, 3 over pi, that would be a 9/4. Pi's go away, plus 6n. Okay, you could do that on your calculator and verify that, but that is how you do that problem. All right, what else? Okay, after thinking about this problem, I think it would be good if we did another one. Let's look at 12. 4 sine of 4t is equal to 1. Okay, now let me do this just a little different. I'm just going to say big A equals 1. So sine is equal to 1 over 4. Sine of A is equal to 1 over 4. Now what we're going to have to do is we are going to have to figure out where sine is 1 over 4. And we're going to do this in radians. Okay, so I just did inverse sine of 1/4 in radians 0.253. Now keep in mind that's a reference angle, so I took that away from pi and I got 2.889. Now remember that's A, so 4t is equal to 0.253 plus 2 pi n. And I'm going to have to divide by 4. So t is equal to 0.253 divided by 4 is 0.0633 plus, and I'm dividing by 4, so that's pi over 2n. Okay, a little sloppy there, sorry about that. All right, let's do this again with 4t is equal to 2.889, right? Plus every period of that, every 2 pi going around there. So plus 2 pi n. Divide by 4, t is equal to, what is 2.889 divided by 4? I have no idea. 0.722. 0.722 plus, remember we're dividing that by 4 too, so that's going to be pi over 2 n. So the answers are here, it's one answer, and right here. Okay, that's how to do that problem. And the others in there are very much like that. Okay, folks, for the last problem in our working together on these problems for our trig class here, trig equations, find all solutions in the interval. So if you went all the way from 0 radians all the way around to 2 pi radians, what angle values would it be a solution to that equation? You know, it could be multiple angle values. You know, we don't know. All right, so let's do that even problem. -3 sine of t is equal to 15 cosine t sine of t. You know, one thing we could do, we can move this part to the right side. 0 is equal to 15 cosine of t sine of t plus 3 sine of t. And we'll do a little trick here. We'll factor out a number and a trig ratio. 0 equals, let's factor out a 3 sine. If I factor out a 3 sine of t, I'm just treating it like it's a variable. Okay, I have what? 5 cosine of t plus 1. Now we're going to use the zero product property. So here I'm going to have 3 sine of t, that could be 0, or 5 cosine t plus 1, that could be 0. In here, when we divide by 3, we have sine of t is equal to 0 over 3, or just 0. And where is sine 0 at? Sine is 0 at 0 radians and pi, okay? Now, so 0 radians and pi. Now how about the cosine? That's a good question. Cosine of t is equal to, we're going to have to move the 1 to the right side, that's going to be negative, and we're going to have to divide by the 5. Now where is cosine -1/5? That's a good question. I'm going to have to get the calculator out and do inverse cosine in radian mode, inverse cosine of 1 divided by 5. Okay, -1 divided by 5. And I have 1.772. 1.772. Okay. Now keep in mind that pi is 3.14, so that angle value is like right over here somewhere. Okay. And 1.722, and if I subtract that from pi minus that, my reference angle is 1.369, so I've got to add that to pi. The other angle value is 1.369 plus pi, which if I just add 3.14, we get 2.51. I'm sorry, 4.51. So what are all my possible values? I have 0. I have pi, or 3.14, 1.772, and 4.51, 0. Those are all my possible answers. Check out that for number 14. Okay, now here's a good question. Sine squared is equal to cosine of t. You know, we could graph this, but another thing that we could do is we could see if we could eliminate one of the sine functions and put the equation all in the terms of one trig ratio. Now, we all know by now sine squared, right? Because sine squared plus cosine squared is equal to 1. So sine squared is equal to 1 minus cosine squared. Let me just write that down there. 1 minus cosine squared t. That's equal to cosine of t. Now, we could do this. How about we just move everybody to the right side? 0 is equal to cosine squared t plus cosine of t plus 1. Now, it would be really nice if that factored nice, but it really didn't factor nice. Let's be mindful. It's a quadratic. Our a is 1, our b is 1, and our c is 1. Okay, so can we use a quadratic formula? Well, yes, we can. So our values are going to be, for cosine of t is equal to negative b plus or minus square root of b squared minus 4a times c. A times c, that's just going to be 1 all over 2a, which is 2. Well, folks, we have a problem right here. And the problem we have right here is that there's just going to be a negative 3 in here. And remember, on the xy plane, we only graph real numbers, but this is an imaginary number. So this is an indication that there is no solution. No solution. Let's take some time to put these two on the calculator and see what's going on. Okay, well, I'm going to show you what happened to me. I made a mistake. I put both of them in my calculator, and then I did a zoom trig, and here I have the two functions there, but look, they are crossing. There is a spot where they're both at the same location, so I must have made a mistake. Maybe you followed and you caught my mistake while I was working the problem, but here it is right here. I did this in too much of a hurry. When I moved that 1 to the right side, that should have been a minus 1. Now notice what that changes. Remember, this is the A, the B, and the C, so that A times C is going to be a negative 1, which that's going to change that to a 1 plus 4, which is a 5, okay, positive 5. And now I'm going to have to figure out what those two solutions are. Okay, so let's review this here. Here's my quadratic, okay, and I divided this out, and I've got this number in radians. That is a positive radian value. If I subtract it from 2 pi, I get this location right here in the fourth quadrant. Now, I had to do this again with the radical